Hey guys, Mr. Gucci here to present your final type of reaction. Okay, this is the video that will briefly explain this reaction type and then run through several examples. So we are talking about single replacement reactions. Okay, a single replacement reaction, unlike a double replacement, replaces one of the elements in an ionic compound with another element. So for example, we have element A, and it is mixed with ionic compound BX. A will come in and take B's place. So now B is the element that's by itself. And now A is bonded with X. Okay, this is a single replacement reaction. Okay, the reactants are an element and an ionic compound. And the products are also an element and an ionic compound. We've just switched which element is the lone element and which element is part of the ionic compound. Okay, now in order for this reaction to go, the single element coming in must be more reactive than the element that it is replacing. And let me show you a video example of a single replacement reaction. Okay, so what we've got here is a piece of copper wire put into a beaker, and let me just slow this a little bit, put into a beaker with some silver nitrate solution. And now as this reaction goes, we see the copper is slowly getting coated in what looks like this black colored fuzz. And as time goes on, forward, we see the water is also starting to get bluer and bluer and bluer as these crystals continue to grow on this piece of copper wire. Okay, now this right here is an example of a single replacement reaction. Let me explain what's going on here. Okay, so what you have is you have a piece of copper metal, so that's just pure elemental copper, and it is combined with a solution of silver nitrate. Okay, so you have elemental copper, all right, and then you have this silver nitrate. Now what goes on is the copper comes in and it replaces the silver. Okay, so the copper ends up bonding with the nitrate and the silver gets the boot. So our products are now silver metal, all right, because it has now been removed from the ionic compound. And the other product is, well, the copper is combining with the nitrate, and so we're going to do a little crisscrossing down here. Copper in this case is 2+. Nitrate is NO3, 1-, so a little crisscrossing. Cu, NO3, 2. Okay, so in this reaction right here, that like crystally gunk growing on the copper is actually pure silver metal. And as the water is turning blue, that's because the water is filling up with copper 2 nitrate. Okay, so this is an example of a single replacement reaction. Okay, now, as I mentioned in the notes here, the single element coming in must be more reactive than the element it is replacing. In this example of silver nitrate mixing with copper wire, the only reason why this reaction works is because copper is a much more reactive element than the silver that it is replacing. Copper is better, and so the nitrate would much rather be bonded to the copper than to the silver. If this reaction was flipped, if I put silver metal in with copper nitrate, there wouldn't be a reaction because nitrate would not want to get rid of the copper and replace it with silver. Right? It's like a relationship, kind of example. Like you would not break up with your boyfriend or girlfriend and choose to go out with someone new unless that person you were going out with would feel, like a better fit. Okay, so this is how single replacement works. Just because you're combining an element and an ionic compound doesn't mean a reaction is going to occur. That single element has to be superior to the element that you are replacing. Okay, and for that we look to the activity series. Okay, this is a ranking of elements by how reactive they are. The higher they are on this list, the more reactive they are and the more things they would replace in an ionic compound. So look at the metals here. Lithium is at the very top of a list. If you put lithium, pure lithium metal in with any other ionic compound, that lithium will replace the element in that compound. Whereas you go to the bottom here, silver, platinum, and gold, these things are not very reactive. And so this is one of the reasons why, it's good to have like gold or platinum jewelry as a chemist, because you could put platinum or gold into pretty much any chemical you can think of, any ionic compound, and it will not react. It will not go into an ionic compound, all right? Because these things are so unreactive. They will replace nothing. Think of it like an elemental hot or not list, okay? Think of it as like an elemental hot or not list. I don't know why that got messed up here. Okay, in order for a single replacement reaction to occur, the single element coming in needs to be higher on the list than the element it is replacing. Okay, so the steps of a single replacement reaction are this. Right, here are the steps. First step, identify all of the charges formed by all of the reactants. All right, so what would the charge of A be as an ion? What would B as an ion be? What would X as an ion be? What are all their charges? And you may have to look at the monoatomic ion list. Next, compare the single element reactant that you're putting into this with the element that it would be replacing. So if A forms a positive ion, it would be replacing whatever the positive ion is in here, right? But you could also, maybe A is a negative ion, in which case it would be replacing the negative ion in this compound, okay? In order for this reaction to occur, the single replacing element has to be higher on the activity series. If not, then there's no reaction. Then you're going to do a little bit of crisscrossing, all right? If this reaction occurs, then you are going to combine this new element with whichever opposite charged ion it would form a compound with, and that is going to be one of your products. The other product is going to be whichever element got booted out is now its own individual product, okay? You're not going to write any charges. It doesn't have any charges. It doesn't have any subscripts. It's just the lone element by itself. And I said no subscripts, but if it's one of the diatomics, then it gets that 2. So if it's like bromine, then it gets like Br2. If it's iodine, it's I2. But if it's anything else, it's just the symbol for that element. And lastly, you would balance. Okay, let me do some of these problems for you. So here's a sample problem. AlBr3 plus Na. AlBr3 plus Na. Okay? AlBr3 plus Na. So I could tell this is a single replacement reaction because we've got an ionic compound and a single element. Okay? The first step, identify the charges that these things form. Aluminum forms a 3+ charge. All right, bromine forms a 1- charge, and sodium forms a 1+ charge. Okay, that is the first step. The second step, all right, is compare like charges on, let me spell it a little bit better. Compare the like charges on the activity series. All right, the lone element, which in this case is sodium, the lone element must be higher. So let's compare sodium and aluminum. This reaction only occurs if sodium is higher on the activity series than aluminum. So let's take a look at the activity series. So is sodium higher than aluminum? Is sodium higher than aluminum? Sodium is right here, and aluminum is down here. So yes, sodium is higher than aluminum. So this reaction occurs. All right, think of it this way. Again, sodium would be like a 7 or 8 on a 10 scale. All right, aluminum is like a 6. All right. So yeah, sodium is going to win this fight. Next step, you're going to crisscross. All right, crisscross. So this reaction happens. So we are going to combine sodium and bromine in a new ionic compound. So I'm going to crisscross. Sodium is 1+. Bromine is 1-. All right, crisscross them. Well, you don't really need to. It's a 1+ and a 1-. You're going to get NaBr. So that's one of your products, okay? NaBr. Br, sodium bromide. But that's not the only product, all right, because aluminum here got the boot. Aluminum is gone. It's no longer in an ionic compound, and so we just write it by itself, okay? Now we ask ourselves briefly, all right, we got to write the lone element. Is it diatomic? Is aluminum diatomic? Well, no, because the diatomic elements are bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. Aluminum is not here. So we would just write Al as our answer, okay? And now the last step, as usual, is to balance. All right, and maybe you can see at this point why I saved this type for last, because it's not that it's like takes a long time once you get the hang of it. It's just there's a lot of things to keep in mind. Okay, you got to do crisscrossing, you got to check a chart, you got to remember which elements are diatomic. There's a lot to balance in here. All right, a lot to keep in your mind. Okay, so aluminum, there's one aluminum, 3 bromines, 1 bromine, so I'm going to put a 3 in front, and now I got to put a 3 in front of the sodium too. And here is your full equation. Okay, let's try another one. Let's try another one now. Okay, let's try the second example. F2 plus AlBr3, right? Actually, we already did an AlBr3, so let's change this. I'm going to change this to something else. 1 second. Okay, I changed it. So we got fluorine gas combining with iron 2 bromide. Let's give that a try. Again, this I can tell is a single replacement reaction because we have 1 element and 1 ionic compound. So this guy might come in and replace one of the elements in this ionic compound. Let's figure this out. First step, of course, is the charges. Fluorine, I know, has a 1- charge. Iron, if you look at the monoatomic ion list, you won't see a charge for iron because iron can have many different possible charges. But it is matched up with a bromine, which is 1-, and since you have 2 bromines, 1-, 1-, the thing that cancels it out is a 2+. Okay, so here we go. These are your ions. Next step. All right, we're going to compare. Compare on the activity series. Okay, so again, we're going to compare the like charges. All right, compare like charges on activity series. And remember, what we're looking for is the single element coming in higher than the element it is replacing? So fluorine is a negative ion, so we're going to compare it to the other negative ion. Is fluorine higher on the activity series than bromine? This reaction only occurs if fluorine is higher than bromine on the activity series. So I go to the activity series and I see, oh, fluorine is at the very top, bromine is farther down. So fluorine will replace pretty much any nonmetal in an ionic compound. Fluorine is like the Channing Tatum of nonmetals. I don't care who you're going out with, you will dump them to go out with Channing Tatum. Okay? So this reaction occurs. Ta-da! All right, next step, we crisscross. All right, and we are going to combine fluorine with the oppositely charged ion that it's now going to be partnered with. All right, iron is 2+ here. All right, 2+. Fluorine is 1-. Okay, and so we crisscross. And we get Fe1, F2. So we got Fe, F2. Now we have another product here. Can't forget. All right. Don't forget the single element product here. In this case, the single element product is bromine. All right. Now, 1 second. We got to ask ourselves, is bromine diatomic? All right, let's take a look here. All right, remember the diatomic elements are bromine. Oh, there it is. Yeah, bromine is diatomic. So we got to make sure that we put Br2 there, okay? Not because it's Br2 over here, but because bromine is diatomic, okay? Lastly, as always in all of these, we balance. All right, so let's see here. We've got two irons. So we got two fluorines and we got two fluorines. We got one iron, we got one iron, we got two bromines, we got two bromines. So this is one of those reactions where it just turns out that everything is already balanced. Just a coefficient of 1 in front of everything, or alternately, just leave it blank. Because if you leave it blank, that implies it's a 1. Okay, great. That's the second one. Let's do another one. Oh, I need to do a blank document. Let me just add a new page. Insert, blank page. Let's do another sample problem. Okay, let's do this one right here. Silver plus copper sulfate. All right, let's see if this reaction occurs. Ag plus Cu SO4. Okay, now first thing, this is a polyatomic ion sulfate, so I'm going to just put it in parentheses just to keep myself safe here. Now again, I can tell this is a single replacement reaction because I have a single element combining with an ionic compound. So if it's anything, it's going to be probably a single replacement. First step is the charges. Silver forms a 1+ charge. Copper is a transition metal. I don't know what charge it forms, but I see it's bonded to sulfate, which is 2-. All right, I know sulfate is 2-, and because there's only one sulfate here, this copper must be 2+. Next step is to compare. Compare the like ions, okay? So this reaction only occurs, again, if the single element coming in, which is positive, replaces the positive element here, all right? So this reaction only occurs if silver is higher on the activity series than copper. This reaction only occurs if silver is higher on the activity series than copper. Sulfate's only going to dump copper if silver is higher on the list, okay? And if you're going out with Channing Tatum, you're not gonna dump him for like Mitch McConnell for some reason, okay? No, the new element coming in has to be better than the one you're starting with. So sulfate is only going to get rid of copper if the silver that's coming in is better. So let's take a look at the activity series. Is silver better, higher than copper on this activity series? So look at the activity series here. They're both pretty low, all right? They're both pretty low. So it's kind of like, would you rather date Mitch McConnell or like, I don't know, who else? You know, my crazy uncle, all right? Who do you prefer? All right, well, let's hear. Copper is higher than silver here. Copper is higher than silver. So copper is better than silver. So this is not a reaction that is going to occur. So the answer here is no reaction, okay? And then it stops. That's it. You don't have to crisscross. You don't have to balance, all right? This reaction doesn't occur because copper is higher, all right? Copper is higher, okay? Cool. Let's do one more problem. And this time I'm going to show you how you're doing this in your homework, okay? So I crossed out the problem that was here and I wrote in a new one. This is not what problem 4 looks like on the homework, okay? So we've got zinc, and then we have got iron 2 phosphate, okay? So first step I'm going to do, I am going to check the charges here, okay? So zinc 2+. Iron, I don't know what the charge of iron is here, but I know that phosphate is 3-. Okay? Iron is, in this case, let's see here, we got 3-, 3-, that's a total of 6-. And if you've got 3 irons here, that means each iron must be 2 plus. Okay, so there we go. We got the charges. Next step, all right, is to compare. We're going to compare the like charges here. So in this case, I'm going to compare the positive zinc to the positive iron. This reaction only occurs if zinc, second, let me make this darker, if zinc is higher than iron. Okay, all right. So let's see, is this true? Is zinc better than iron? Remember, phosphate is only going to break up with iron if it can go out with zinc, all right, if zinc is better, all right? So again, like, oh, I don't know. All right, so let's see here. Let's take a look at the activity series. Is zinc higher than iron on this activity series? So go to the activity series. Let's see. Zinc is higher than iron on this activity series. So this reaction does occur, all right, because zinc is higher on the activity series. And so now we have to combine zinc with the phosphate. Okay, we're going to bond. We're going to crisscross. Okay, so zinc, 2 plus, phosphate, which is PO4, 3 minus. We have got to crisscross here. Okay, and so we get Zn3 PO4 2. All right, that's one of our products here. All right, see if I can squeeze it in. Zn3 PO4 2. Okay, and the other product is going to be the single element. Oh, by the way, does this reaction occur? Does it occur? Yes, it does occur. All right, the reaction does occur. Don't forget, you got to tell me if the reaction occurs down here. All right, so next up, we got to do the single element. The single element that got the boot here is the iron. All right, now, is it diatomic? Is iron diatomic? All right, well, the diatomic elements are bromine, no. Iodine, no. Nitrogen, no. Chlorine, no. Hydrogen, no. Oxygen, no. Fluorine, well, not fluorine. So it is not diatomic. So we just leave it Fe with nothing. And lastly, we balance. Okay, we balance. Let me erase some of the superfluous stuff here to kind of make it a little bit easier to see. Okay. Okay, so here we go. We got, oopsie. Here we go. We got a zinc and 3 zincs. So I'm going to put a 3 here. We've got 3 irons and 1 iron. So I'm going to put a 3 here. And then we've got 2 phosphates and 2 phosphates. Okay, that's it. That's balanced. Okay, so this is how you do single replacement reaction types. I hope this helped, guys. Have a great day.